Hello everyone and welcome to the course on Quantitative Research Methods in Social Sciences. I'm Dr. Haihu Guo from the Department of Society and Health, Faculty of Social Sciences and Humanities, Mahidol University. Today we will explore an essential concept in the research process, sampling design. In this session, we will discuss four key topics. First, we will look at the definitions of population and sample, and understand the difference between the two. Then, we will explore how to determine an appropriate sample size, including a simple calculation formula. Next, we will go over the types of probability sampling methods, such as simple random sampling and stratified sampling. Finally, we will examine non-probability sampling methods, like convenience sampling and snowball sampling. By the end of this session, you should be able to select and justify a suitable sampling strategy for your own research. Before diving into the details, let's take a quick look at what we will cover. This topic helps you understand how to choose the right people or units to study from a larger group. You will learn about different sampling methods, how to calculate how many people to include, and why these decisions matter for research quality. Let's begin with the concept of population. In research, population refers to the entire group that you want to study. This could be individuals, such as people or students, or it could be objects, like books, buildings, or websites. We usually talk about two kinds of populations. The target population is the ideal group that we aim to understand, for example, all nurses in Thailand. But often, we cannot reach the whole group. So we work with the accessible population, for example, nurses in Bangkok hospitals. This distinction is important for defining the scope of your research. Now let's talk about what a sample is. A sample is a subset of a population that we actually study. Since it's often impossible to study every member of a population, we rely on samples to collect data efficiently. A good sample allows us to make generalizations about the population. For instance, if you randomly select 400 nurses out of a total population of 10,000 nurses, that group of 400 becomes your sample. The more accurately your sample reflects the population, the more confident you can be in your research findings. Many students confuse the sampling frame with a population. The sampling frame is your actual list. Like a Venn directory, the sampling unit is what you are selecting, a person, a household, and so on. If your frame is incomplete or outdated, your results may not reflect the real population. This slide illustrates the relationship between a population and a sample. Suppose your population is all high school teachers in one country. You probably cannot study every single teacher, so you take a smaller group, a sample, to represent them. The goal is to ensure that the sample reflects the key characteristics of the population, so your results remain meaningful and applicable. A good sample has four important characteristics. First, it must be representative, meaning it accurately mirrors the larger population. Second, it should be unbiased. There should be no favoritism in how participants are chosen. Third, it must be adequate in size, big enough to provide statistically reliable results. Finally, it should be feasible, meaning you can realistically gather the data with your available time, resources, and budget. Balancing these characteristics is essential to ensure the quality of your research. The size of your sample directly affects the quality of your research. If your sample is too small, you may not detect true effects, and your findings could be inaccurate. On the other hand, a sample that is too large might consume more time and resources than necessary. So determining the right sample size is about finding the optimal point, where your results are both reliable and efficient. Several factors influence how large your sample should be. First, population size, or the total number of individuals you want to study. Second, the margin of error. This is how much error you are willing to tolerate, commonly set at 0.05. Third, the confidence level, which is usually 95%, reflecting how certain you want to be about your results. Lastly, population variability. The more diverse the population, the larger the sample needed to capture the variation accurately. One commonly used formula for calculating sample size is Yamani's formula. It's especially popular in social sciences because it's simple and practical. This formula uses the total population and the margin of error. Typically, error is set at 0.05 or 0.01. Using this formula helps researchers determine a reasonable sample size without needing complex software. Let's apply Yamani's formula. Say your population is 1,000 people, and you want a margin of error of 0.05. Plugging the numbers into the formula, you will get a required sample size of 286. You can also use online tools such as Rawsoft or SurveyMonkey's calculator to confirm the result. These tools simplify the process and reduce calculation errors. Here is an example of using the Rawsoft online sample size calculator. It's a free tool that allows you to determine how many participants you need for your study or for your survey. We set the margin of error at 5% and the confidence level at 95%, both common choices in research. The population size is 20,000, and the response distribution is 50%, which gives the largest sample size. Based on this, the recommended sample size is 377. You can also see how different sample sizes or confidence levels affect the margin of error. This tool helps ensure your sample is statistically reliable. This is another tool for calculating sample size for Monkey Survey. You just input the population size, set the confidence level, typically 95%, and choose the margin of error, commonly 5%. It's easy to use and helpful for planning online surveys. You can get it at the link shown below the slide. There are two main categories of sampling strategies in quantitative research: the probability sampling and the non-probability sampling. The key difference lies in whether every member of the population has an equal chance of being selected. Let's take a closer look at each category and the specific methods under them. In probability sampling, each individual in the population has a known non-zero chance of being selected. This makes the sample more representative and suitable for generalizing results. In contrast, non-probability sampling does not guarantee equal chances for all. Instead, Participants are chosen based on factors like convenience or availability, while less rigorous, non-probability methods are useful when working with hard-to-reach populations. Here's a quick side-by-side comparison. Probability sampling gives every individual a known chance of selection and allows us to generalize our results to the population. Non-probability sampling is more practical and easier to implement, but it may limit generalizability. Both types have their own strengths and limitations, and choosing between them depends on your own research design, resources, and goals. There are 5 types of probability sampling: simple random sampling, systematic random sampling, stratified random sampling, cluster sampling, and multi-stage sampling. Each method has its advantages. Depending on the research question, resources, and population structure. In simple random sampling, each member of the population has an equal and independent chance of being selected. It's like drawing names from a hat. Every name has the same chance. This method is widely used and considered the most rigorous. However, it requires a complete list of the population, which may not always be available. With systematic sampling, you select every individual from a list or a queue. For example, if you need 500 people from a population of 1,000, you would select every second person. It's simpler than random sampling and ensures that selections are spread evenly. Just make sure the list isn't arranged in a way that might create bias. Stratified sampling involves dividing your population into meaningful subgroups of strata, like gender, age, or income levels. Then you randomly sample from each subgroup. This method ensures that all key subgroups are included, making your sample more representative of the total population. In cluster sampling, you divide the population into clusters, such as schools, communities, or provinces, then randomly select entire clusters. This method is efficient for large dispersed populations. However, clusters may differ from each other, so results might be less precise. Multi-stage sampling is used to select samples into 2 or more stages. For example, first randomly select province, then districts, then schools, and finally students within those schools. This approach is cost-effective and useful for large-scale surveys. It also reduces the need for a complete list of all individuals at the start. Now let's look at non-probability sampling methods. These are often used when the population is hard to access or identify. The most common types include convenience sampling and snowball sampling. Although they are less rigorous, they are useful in specific contexts, particularly in qualitative or exploratory research. Convenience sampling involves selecting participants who are available and willing to participate. For example, recruiting students on your campus. While this method is fast and easy, it may introduce bias and limit how well the results apply to other situations. Still, it's often used in pilot studies or when resources are limited. Snowball sampling is useful for studying hidden or rare populations. You begin with a few known participants, who then refer others from their network. This method helps expand your sample, especially when there is no clear list of the population. It's commonly used in studies of migrants, drug users, or people with rare conditions. We now come to the end of this session. Today we have discussed what population and sample mean, how to determine sample size using tools, and how to apply both probability and non-probability sampling methods. Thank you, and see you in the following sections.